example, we are studying the consumption patterns of two areas. One is in the city and one is in the countryside. So generally, you're going to expect maybe those live in the city will be richer. Okay, so they may not necessarily be richer, but because there are more department stores and a lot of shops in the city, so you may expect people living in the city will spend more. Of course, countryside, there are not as many big stores or department stores or shops. Therefore, you're going to expect that for those people live in the countryside, they spend a little bit less. And as you may know, generally people will go to the city for shopping rather than go to the countryside for shopping. So we will expect this is what's going on. So the first question is, we have two different types, right? The first type is people live in city, and the second type is people live in countryside. And for these two areas, the sample we get, the first one from the city, we have 50 samples. The second one from the countryside, we also have 50 samples. Of course, we want to test whether they have the same kind of consumption patterns. So basically, that means we want to test whether the mean is equal to each other or not. So the null hypothesis is mu1 equals to mu2, right? And the alternative hypothesis is mu1 not equal to mu2. In this case, we can use traditional hypothesis test, right? We can use traditional hypothesis test when we use x bar 1, okay, and then x bar 2. And you remember that this is n1, okay, the sample size is equal to 50. The second one, the sample size is also equal to 50. So what kind of distribution we should use? What kind of distribution we should use? T or we should use Z? Which one? We should use Z, standard normal, right? Because this is larger than 30, right? This is larger than 30. But remember, we talked about this before. When we say we use Z distribution, but then we have to know whether the variance are equal to each other or not. Because if the variance are equal to each other, then we have to use a different kind of formula, okay? If we don't know anything about the variance, okay, then we use S1 squared to estimate sigma 1 squared, right? And S2 squared to estimate sigma 2 squared, right? Remember this? But somehow, if sigma 1 squared is equal to sigma 2 squared, we have to use a different formula. We have to use SP squared. Remember that? And what is SP squared? SP squared is N1 minus 1 plus N2 minus 2. And this is N1 minus 1 S1 squared plus N2 minus 1 S2 squared, right? If we know sigma 1 squared is equal to sigma 2 squared, then we have to use SP squared, okay? But suppose we don't know anything about it, then we say S1 squared to estimate sigma 1 squared, S2 squared to estimate sigma 2 squared, right? Okay. So the same questions comes up. What is the question? We have to test first whether variance, okay, the variance is equal to each other or not. So let me try this. So we have to remember this. This is the information we have. The mean, the sample mean from the city is 7,800. And the sample mean from the countryside is 6,500. And the standard deviation is 1,200 for the city and 1,000 for the countryside. Okay? So because the first step we want to test, okay? The first one is that we can use traditional hypothesis test for this question. The second one, of course, is ANOVA. If we want to use ANOVA, we have to first make sure that this one is equal to this one, right? Sigma 1 squared is equal to sigma 2 squared. Why? Because if you want to use ANOVA, this is one of the assumptions we make. So you have to make sure that sigma 1 squared is equal to sigma 2 squared. If they are equal to each other, then you can use ANOVA. If they are not equal to each other, can you use ANOVA? No, okay? So first we have to test that. Okay, so we test whether these two are equal to each other or not, right? And of course, the null hypothesis is they are not equal to each other. And so alpha should be equal to 5%. But because alpha is 5%, and this is a two-tailed test, okay? This is alpha 5%, this is a two-tailed test, so you should check F, okay? Because we have the sample size for the first one is 50. The sample size for the second one is also 50. So what is the critical value? The critical value should be 49, 49, and 0.025, right? Okay. So we know S1 squared is 1200 to 2's power, right? And S2 squared is 10,000 to 2's power. And if you still remember, okay, this is what we have, right? And basically, this is equal to sigma x squared, sigma y squared times sx squared, sy squared, right? If h naught is true, this is equal to 1. So if you are testing whether these two variances are equal to each other or not, you only need to have this, okay? So sx squared, so we have to get f naught, right? F naught is 1200 squared divided by 1000 squared. So what you get? 1.44, okay? And in this case, if you check the table, okay, you should be able to find out, okay? Check the table. This is actually less than the critical value. So F naught is less than the critical value, right? So then what would you do? You say accept H naught. So what does that mean? That means in this question, actually the variances are from the countryside and the variances from the city is the same. Okay, they are the same. Questions? Any questions? So basically, this is one of the typical questions I may have in the final, okay? I give you a whole bunch of numbers. And then you test first whether the variances are equal to each other or not. And then from there, you're going to move forward to test, okay, whether the mean, okay, whether the mean is equal to each other or not. And let us try to use F test first, okay, F test, that's ANOVA, okay? Any questions? So first, we have already done this. We already test the variance, right? And the variance, indeed, they are equal to each other. Of course, if there's any question in the final, I will give you the F table, okay? F table. And we just talk about how to use F table, okay? And you have to remember, remind yourself, whether it's a one-tailed test or two-tailed test. This is a two-tailed test, right? So even though the significant level is 5%, you should use 0.025 because it's a 5% significant level and it's two-tailed test. Okay, we are done with this. Then let's get to this part, okay? So we already know, according to the first test, we know sigma 1 squared is equal to sigma 2 squared. So that means the variance, okay, is equal to each other. And so we can use ANOVA. Okay, we can use ANOVA. So can anyone tell me what should be the number here? What should the number here? Because we have two different areas, right? We have two different areas. So how much it should be here? It should be equal to 1, okay? And then we know for each one, we have a sample of 50. 50 samples from the countryside, 50 samples from the city. So how much it should be here? We have 50 samples from the countryside, 50 samples from the city. How much it should be here? Can anyone tell me what should be here? N1 is equal to 50, right? N2 is also equal. How much should that be? Can anyone give me any number? Try guess, okay? Chen Xiangru, what should be the number here? Wang Xiaoping. If you are not able to do this, I'm quite sure you will be failed. What's the number? Here, degrees of freedom. No. Your turn. What should be the number here? Because you know there are two areas, right? So there are two factors, okay? So it is 1. What about here? No. 98, right? It should be 98 because you have 50 from the countryside and 51 from the city, right? So the total is 100. 100 minus 2, right? Because you have, so N1, summation Ni, right? N1 plus N2 and minus 2, okay? So it should be 100. And what about here? It should be I suppose you should know by this time. What's the number here? Excuse me? Are you sure? You. It's your turn, okay. What should be the number here? Excuse me? 99, right. 99, because it's summation Ni minus 1, right? So it is N1 plus N2 minus 1. So it should be 99, okay? Okay. So now we're going to get to something even more difficult, okay? But really, if you know the formula, you know the definition, everyone should be easy, okay? Everyone, you can fill in the number quite easily. Okay. Here, what you need to get, you need to get the factors, right? Degrees, the square of deviation due to factors, okay? Square deviation due to factors. So it is this one. So you want to check SSF, this is the formula you need to get, right? Okay. So now, in this case, you don't know x bar g. You don't know this. So you have to calculate it. Can anyone tell me? Because x bar 1 is here, right? X bar 2 is here. So you have these two information, okay? And you don't have this, x bar g. So can anyone tell me how to get x bar g? Can anyone tell me how to get x bar g? Okay, let me do this, okay? Then the next hour, I will work on something that you have to tell me, okay? So, in this case, you have 50 sample from the first one, right? So it should be 50 times 7,800 plus 50 times 6,500 and divided by how many? 100, right? So can anyone give me this number? What should be the number here? Okay, so it's 7150. 7150, okay? And so here, you know, this is from I1 to R, J1 to Ni, right? So how many there? It should be 50, right? From J to Ni, the total is 50. And you have to remember, this one is x bar I, right? And this one is x bar G. Both of these, they are not related to J, right? They are not related to J. So basically, it is C. You want to check how many Ni do you have, right? If there is 50, in this case, that is 50, right? So 50 times this one, okay? Because there are two areas, one countryside, one city and two countryside, right? And each one has 50 samples, okay? So then SSF should be equal to 50. Because from here, you have 50 samples from the city, right? And times 7,800, that's x bar 1, okay? Minus 7,150 square, plus. So this is from the city, and then you have to another one. Another one is from the countryside, right? Times it should be 6,500, right? Minus 7,150 square. So basically, this formula, okay, corresponds to the formula here, okay? This is the formula you have, x bar 1, x bar 2, right? X bar 1 minus G, x bar G. And times how many you have? Because here is from 1 to Ni. Okay, so there are 50 samples, so you time it by 50. The second one, the same thing, right? But it is from the countryside. 50 times 6,500 minus this one. X bar 2 minus x bar G. Okay, give me this number here. Okay, so we're gonna, okay, give me. You want to try something now, okay? Otherwise, you're going to get into big trouble when you do the test. So what should be the number here? How much? 4?
1,220,000.
Okay, so then it's 42250,000. And so in terms of mean square, right, MSF, it should be 42250. Okay? Okay, any questions so far? We are done with SSF. So we finished this part. Okay? Any questions? You want to know how to do all these things, plug in the numbers and get what you need. Okay? Okay, the second one. The second one is more difficult because we don't have any we don't have information on any individual item, right? We need to have Xij, but we don't have Xij, right? So how to get that? So in this case, so last time when we discussed ANOVA, actually I gave you some hint. It is very helpful to have information on standard deviation or variance. Okay, why? Because okay, if you want to get the sample variance, okay, you want to get sample variance, then this is the formula, right? Okay, this is the formula. But if you look at this part, okay, this part is exactly this part, right? So what does that mean? If you want to get SSE, you need to know standard deviation or variance, because here correspond to this part. So ni minus 1 times si squared is equal to summation xij minus x bar I squared, right? Okay, so that means if we want to calculate SSE, right, you just need to have this. Okay, I'll keep this on board, and then we move on to calculate SSE. Okay? So because in this case we know summation xij minus x bar I squared is actually summation ni minus 1 times si squared, right? So basically this formula can be written as this part, okay? So then in this case it should be easy, right? You want to get SSE, so that's 49 times 1200 squared plus 49 times 1000 squared, right? So please give me this number. What's the total here? So when in the final you want to get your calculator larger than 8 digits, because in this case this one should be more than 8 digits. If you have a calculator less than 8 digits, you won't be able to get the answer. Anyway, one 956. No. Okay? So it should be here. 119560000. Okay? And because here the degrees of freedom, I think there's something wrong. Is the degrees of freedom 100? No, it's not, right? It should be 98. It should be 98. Because the sample 50 and 50, right? And minus, you have 2 factors, right? So here it should be 98. Okay, you want to change this. So can anyone give me this number? Okay, we want to get MSE, right? MSE is this number divided by 98. So can anyone tell me what's the number there? So that's 1 billion and 11. Anyway, it's a long number. So anyone give me this if you have got it. What is the number? 1, 2, 2, and 40? Okay. Okay. So basically, this is what we get, right? In this case, you don't have to calculate SST because if you want to do F-test, you don't need SST. Okay, you don't need that. Okay, so then basically, from this information, right, you have mean x bar 1, x bar 2, and standard deviation here. From here, you can get all the numbers, okay, all the numbers you need to do ANOVA, okay? And then the next step is to get F0, right? So what is F0? F0 is 42250 and divided by 1220. Okay, can anyone give me this number here? 33, okay, 34.63. Okay, so this is what you get. Of course, in this case, you have to check with the critical value, right? So what should be the critical value? the critical value is F star, degrees of freedom 1 and 98, and because the significant level is 5%. And as you may know, ANOVA is a right tail test. Okay, this is a right tail test. So if the significant level is 5%, then here it should be 0.05, right? Okay. Somehow let us check the book. Okay. Let us try to figure out what is the critical value there. Okay. So it should be 5%, and but in this case we only have 120, right? We don't have 98. So in this case we're gonna do two things. First one, we check 160. Okay, we check F160, and then the second one you check F1 120, right? So let us try. If it is 160, how much is it? It is equal to 4.00, right? And for this one is equal to 3.92, right? And F198 should be in between, okay? Even though we don't know the exact value, right? But we know this value should be in between. So it should be between 4 and 3.92, right? And how much do we get? We get 34.63. So what's your conclusion? Is mu1 equal to mu2? Mu1 equals to mu2? No, right? Because F naught, the observation value is much greater F star. So the conclusion is the consumption pattern of the city and the countryside, it should be different. Okay, the consumption pattern of the city and the countryside should be different. Okay, any questions? Any questions so far? Okay, then after we are done with this, then we will turn to the traditional hypothesis test. Okay, so this is ANOVA, right? This is ANOVA, and let us turn to traditional test. The traditional test because in this case it is a we use normal distribution, right? In this case we use normal distribution. Okay, and the significant level is equal to 5%. But remember, when we do ANOVA, it is a right tail test. But when we do the traditional type, this is a two tail test. Okay, so corresponding to the 0.025, here the z should be equal to 1.96. And the z here, negative 1.96, right? And as we have done, we know that sigma 1 square is actually equal to sigma 2 square. So we need to use SP square, right? And here it is 98, right? Because it is 50 minus 1 plus 50 minus 1, right? And here is 49 times 1200 to 2's power, and 49 times 1000 to 2's power. And basically, what is this? This is MSE, right? Okay, so that is 1220. Okay. And then we know x bar 1 is 7800, right? x bar 2 is equal to 6,500, okay? And we want to get the we want to get the value, okay? Here we can get a z. From here we can get a z and see if it is greater than this one. If it is greater than this one, so that means it is greater than the critical value. So you say they are different, okay? They are different. So then we have the z observation value is equal to 7,800 minus 6,500 and minus mu1 minus mu2, right? But because mu1 minus mu2, when the null hypothesis is true, this one is actually equal to how much? 0, right? And here you have sp squared times 1 over n1 and 1 over n2, right? Okay, so basically here you have 1,300, okay? And here you have square root 1,220,000 times 2 over 50, because it is 1 over 50 and 1 over 50, right? So that you have 2 over 50. If you have any questions to this point, please raise your hands. The first one, we have done that with ANOVA. And the second one is traditional hypothesis test. Remember, traditional hypothesis test and how to calculate beta is also in the final. Okay, you have to know all these. Okay, so here you have plug in the number there. Okay, plug in the number there, and this is the variance. Standard deviation you use, right? So can anyone tell me what's this number? What's this number? So first you have to calculate this, right? And square root it and divide it by 1,300. I think it should be something around 5.8. Okay, 5.88. Okay, this is going to be 5.88. And in comparison to this one, what do you get? This is only 1.96, right? And this one is much higher than 1.96. So what would you do? You do the same thing. You come to the same conclusion. You will reject null hypothesis and accept alternative hypothesis. Okay? So from ANOVA and from traditional hypothesis test, the conclusion is the same. We reject null hypothesis. That means the consumption pattern of countryside and city are different. Okay, they should be different. Any questions? Okay, so then we will get to another question. Okay. So let us get to another example. Okay, one more example. Okay, the first question is test. The second question is okay, so then we should do this one first. Can anyone tell me what's the procedure to follow this? So for this one, first you have to use F-test, right? F-test. And the sample size for the first one is 16. For the second one is also 16. Suppose we want to do this by traditional hypothesis test. Which distribution should we use? If this is to be done by traditional hypothesis test, which distribution should we use? We should use T distribution or Z distribution. Which one? In this case, we should use T or Z. We should use T because the sample size is less than 30, okay? If you want to do this by traditional hypothesis test, you have to use T distribution, okay? Okay, then we should test this one first, right? So then H naught sigma 1 square equal to sigma 2 square, H1 sigma 1 square not equal to sigma 2 square. Because this is a two-tailed test, right? If the alpha is 0.05, okay, then the critical value you have to check is F star. Can anyone tell me what's the degrees of freedom here? Because for this one, okay, for this one, what is the degrees of freedom? It should be 15 and 15 because sample 1, 16, sample 2, also 16, okay? And then what is here? It should be 0.025 because it is a two-tailed test. Okay, this is a two-tailed test. Okay, and as you remember, if you want to test whether the variances are equal to each other or not, you should have F0 equal to what? 4.5 divided by 3.9, right? Can anyone give me this number? $1.15? Okay. So if you check the table, okay, let us try again, okay? Let us check the table. But unfortunately, there is no 0.025 in this case, right? So then what should we do? Page 761, right? Page 761 is the 0.05 significant level, right? And so let's look at page 762. So you have to check first degrees of freedom 15 and 15, right? So 15 and 15, what you get? 15 and 15 you get actually that is 3.52, right? So this one, F15, 15.01 is equal to 3.52, okay? Okay. So as you may know, actually this is a even higher significant level. I mean, even lower significant level. And this one, 1.15 is lower than this, okay? Then let us check again. Page 761. We're going to check the other one, right? That is F15, 15, and 0.05. What is this? This is equal to 2.40, right? 2.40. So as you can tell, this number is much less than this one and also much less than this one, right? So what would you say? You would say F naught should be less than the critical value 15, 15, and 0.025, right? So what does that mean? That means you will accept the null hypothesis. The null hypothesis is that the variance are equal to each other, okay? Okay. In this case, because there is no exact number we need, right? So then we try to figure out, because this value, okay, this value should be between, should be between these two values, right? This value should be in between, okay? So if this number is less than both of this, then this one should be true, okay? This one should be true. So we are done with the first one, okay? Any questions? Let us take a break and we will continue the example in next hour. And x bar I square minus, this one is I, right? This one is j. And this one is x bar g. So as you can tell, actually x bar g is not affected by j, right? This is a constant, so we can move that thing out. But anyway, let us take it step by step. Summation, so 2 summation x bar I, x bar g, plus summation x bar g square. Okay? And this is I from 1 to R, j from 1 to ni. The same thing here, 1 to R, 1 to ni, 1 to R, and 1 to ni. Okay. Okay, so what do you get here? In this case, this I, because the first step, the first summation, if you want to add, you add from j, right, and 1 to ni. So how many x bar I square here? For each one, right? For each machine, you produce ni products, right? And so in each case, you add x bar I square ni times, right? So what do you get? Summation I equals 1 from 1 to R ni x bar I square, right? Because you want to get rid of this. And how many times do you add? You add from 1 to ni, okay? So let me do this. J from 1 to ni and x bar I square, right? Because first one, x bar I square, right? The second one, also x bar I square, right? How many times you have ni times, right? Because here. So this one should be equal to this one. Okay? Any more questions? And then let us talk about this one. The same thing, right? Because this is x bar g square, so that means it is not affected by j, neither is it affected by I, right? And we say summation I from 1 to R, j from 1 to ni. What is this thing equal to? It's equal to n, right? So what do you get? You get n x bar g square. Okay? Okay, so I will erase this. So this part shows this one is equal to this part here. Okay? Okay, the difficult part is here. Okay, the difficult part is here. Okay, so we can move x bar g out, right? We can move x bar g out. So this is equal to x bar g, okay, summation and summation. Because this, we say this part is equal to ni x bar I square, right? So then, if we move this out, okay, we already moved it out, and so this part is actually the same as this part, except it is square. It is not. right? So what does this mean? This means that this is I from 1 to R ni x bar I, right? Basically, we already agree this part is equal to this part, right? And this part is basically the same thing here. The difference is it is square, it is not, right? So in this case, we can say this one should be true. Okay, this one should be true. Okay, then what is this one? Let us try here. X bar I is equal to 1 over ni summation xij, j from 1 to ni, right? Okay? We are looking at individual machines. Before we discuss this kind of problem with several variables, we only have x bar is equal to 1 over n summation xi, right? So this is the original formula. But now we are dealing with several different machines. Okay, we have several small populations, several small samples. So in this case, we have to deal with x bar I. That's the mean, the sample mean of each machine. Okay, and it is divided by ni. That's the number of samples you have, and this one is xij, right? J from 1 to ni. Okay, any questions? Okay, then from here you know x bar I is equal to, times ni is equal to summation j from 1 to ni xij, right? Okay, so actually this part is what you see here, right? This part is actually equal to this part, right? Okay? And so, if you look at this whole thing, what is this whole thing equal to? Because in this case, we are only looking at the ith machine, right? We are only looking at one machine at a time. And this one is the ith machine, right? And how many machines we are looking at in this case? Because from this part, we are only looking at one machine, right? But actually, because of this summation, how many machines we are looking at? Actually, we are looking at all of the machines because it is from 1 to R, right? Okay, from 1 to R. And so if we get a summation here, that is I from 1 to R, so then we have also to add from I is from 1 to R, right? So what do you get? You get summation, okay, xij. Okay, from here, you know, you are dealing with every sample, right? You are dealing with every sample. And so this one is actually equal to n times x bar g, because x bar g is equal to 1 over n summation xij, right? So because of this, we know, okay, because of this we know, this one is actually equal to n times x bar g, okay? This one is actually equal to n times x bar g. You want to be careful because the formula is getting more complicated, so you have to remember each step, how you get to the next step, okay? So basically, we already know this part is equal to n times x bar g squared, right? And this part should be equal to 2 times x bar g times n times x bar g, right? So then the whole thing should be equal to r over 1 over r minus 1 expectation summation I 1 to r ni xi bar square minus 2n x bar g square plus nx bar g squared. Okay? So this is what we get. So then we can simplify further. Actually, what do we get? We get 1 over r minus 1 expectation summation ni x bar I square, I from 1 to r, minus nx bar g squared. Okay? Any questions so far? So it is a little bit complicated. You have to get step by step, okay? Compare the formula and compare which part, okay? Say you are looking at this part, you have to get it from here to here, okay? Remember how you get those things there. Any questions? Okay, then there's something we know, right? There's something we know here, okay? But before we do that, let us simplify it further. Okay, anyway, we can deal with it here. Okay, so if you know x and the mean is mu x, the variance is sigma x squared, right? If you know that, then what about x bar? X bar would be mu x, and this one is sigma x squared divided by n, right? Okay? Okay. But what about here? Because we have expectation move inside, right? This part has to be we have to do expectation here. And so actually you are looking at expectation x bar square, right? Okay? Can anyone tell me what is expectation of x squared? What is this equal to? Expectation x squared. It will be in the final, okay? So what is this equal to? It is equal to two parts. The first part is mu x squared, right? The second part is vx, okay? But here you are looking at this one, right? So it is mu x bar squared plus vx bar, right? And mu x bar is actually equal to mu x, right? X is here and x bar is here. The mean is the same, right? The mean is the same. But this one, of course, is different. Okay, so what is the next step? So you have to remember all these formulas. So let us continue. Let us stop here. You have to do teaching evaluation. Hypothesis test is about whether mu1 is equal to mu2. We just mentioned, of course, we can use traditional hypothesis test. And if we use traditional hypothesis test, we should use t distribution. And the reason is because the sample size is very small. But first, let us try by ANOVA. So if it is ANOVA, then again, we have to fill in the table. Okay? So this table is very important to you. You have to know the whole thing here, how to fill in the numbers. And with this number, with this table, you can do everything, okay? So first one, how many factors here? In terms of the degrees of freedom for the factor, what should be the number here? What should be the number here for these questions? For this question, degrees of freedom, it should be equal to degrees of freedom. What should be here? Okay, the lady with pink clothes, with pink sweater, what should be the number here? It is you, right. Pink. You wear pink sweater, yes. You have two different things, right? So what should be the degrees of freedom for the factor here? Give me a number. 1, okay? Okay, what about degrees of freedom for the error? Your turn. So what should be the degrees of freedom here? You have first sample 16, second sample also 16. What should be the number here? It should be 30, right? 16 plus 16 minus 2, right? 16 plus 16 minus 2. What about here? It should be 31, okay? Again, we're gonna try to get this one, right? This is summation, summation. We are looking across machines. X bar I minus X bar G squared. And the same thing here, summation, summation, Xij minus X bar I squared. And as a matter of fact, this one is equal to summation Ni minus 1 Si squared, right? Okay. Here we don't have X bar G, so we need to get X bar G first. Can anyone tell me how to get X bar G? It should be 16 times 21 plus 16 times 19 divided by 32, right? So it should be 20, okay? So we want to calculate SSF, okay? SSF is equal to 16 times 21 minus 20 to 2's power plus 16, 19 minus 20 to 2's power, right? Because here you have X bar 1 minus X bar G, right? And this is Ij from 1 to Ni, from 1 to R, right? So you have 16 samples. So it's 16 times this one. So it should be equal to 32, right? So you have 32 here. Then MSF is also equal to 32. Okay? Any questions so far? Then we need to calculate SSE, right? The same thing there. We have 15 times 4.5 plus 15 times 3.9. Okay, can anyone give me this number? One, 2, 6. Okay, so here is 1, 2, 6. So please give me this number here. It should be 126 divided by 30. 4.2. Are you sure this is 126? Would you like to try again? Okay. Okay. After we have get all these numbers, then can I erase this? Okay. So basically, these are all the formulas you need to know. Okay, then you want to calculate F naught, right? F naught is equal to 32 divided by 4.2. So please give me this number here. 7.62. Okay, 7.62. The same thing, because this is the observation value, right? We have to compare this value with the critical value. The critical value is F star 1, right? Degrees of freedom 1, and then 30, and then the degrees of, the significant level is 0.05, right? Okay, so please find this number for me. Okay, check the table and give me this number. Just want to make sure that you understand what's going on here. So the girl with yellow coat, please find a value for me. It is on page 761, I believe. Find this value. Okay, degrees of freedom 1 and 30. And the significant level is 0.05. 4.9? 4.17. Okay? So in this case, apparently, F naught is greater than F star, right? So what would you say? The mean is equal to each other or not? No, right? They are not equal to each other. Okay. Any questions? Any questions? Okay. Let us get another example. This example will be okay, we have all these information here, okay, all this information. The sample size is equal to, the first, second, third, and fourth, the sample size are all equal to 50, okay? And then you have the sample mean for the first one, second one, third one, and fourth one, and the sample deviation, sample standard deviation, 11, 12, etc. So let us try to figure out what should be the number here. What should be the number here? The girl with the blue coat, what should be the number here? Excuse me? Degrees of freedom. What should be the number here? Three, right? What about here? Degrees of freedom. The girl with white coat. What should be the number here? With, the next, what should be the degrees of freedom here? Your turn. 196. Because the sample size of the total is 200, right? 200 minus 4. Okay, you get 196. And here, of course, is 199, right? And then the same thing, okay, you need to calculate this and then you need to calculate that, right? So basically, it's kind of a routine. If you get familiar with all the procedure, it's just routine, okay? It should be easy to you, okay? So this will be your homework, okay? Do it yourself, okay? Try to do that yourself. You should be able to get it. And then let's get a brief review on how to calculate beta, okay? So let us say it is a two-tailed test here, right? So here to the right, you will take action A1. Here you will take action A0. Here you will take action A0. And here you will take action A1, right? And let us say it is like this. Okay? So you know here within this area it is 1 minus alpha, right? And here is alpha over 2, alpha over 2. And then this is H0 is true, right? This is H0 is true. But here it is H1 is true. So here what you get, you're going to get this is beta, okay? And this is the right-hand side critical value. And here it is the left-hand side critical value. And here is the same thing, X star R and X star L, right? And you have area A and area B. A plus B is equal to 1 minus beta. Okay, probability of A minus B. Okay. So basically, what we're going to have for the final, as a matter of fact, it's going to be from the beginning to the end. So you need to be able to calculate X bar and mu, right? And then S1 square and sigma 1 square. All these are still required. And then you have the normal distribution, standard normal distribution. And when the sample size is small or when the population variance is unknown, you have to use T distribution, right? Okay? And of course, T distribution is related to chi-square distribution, and chi-square distribution is related to F distribution. And for the estimation, we have point estimation, we have interval estimation. And for the estimation, you need to estimate mu, right? Sometimes you need to estimate mu. Sometimes you need to estimate sigma x squared, right? And sometimes you need to estimate mu1 minus mu2, right? And sometimes you need to estimate P1 minus P2, okay? And in terms of hypothesis test, sometimes you may test whether these two are equal to each other or not, okay? Smaller or equal to, right? So in this case, you have to use right tail test. In this case, you have to use left tail test, okay? And in this case, it is two tail test, okay? And when you have to test many things, then you have to use, the means of several population, then you use ANOVA, okay? And before you test ANOVA, sometimes you need to test whether this is true or not. Then you use F test, okay? But this is a two-tail test because whether test they are equal to each other or not. So it is a two-tail test. But when you do ANOVA, it is a right-tail test, okay? So basically, this is what we will have for the final. Any questions? Any questions? Good luck to your final.